Hello students, and welcome back to the second video of the revision series for the end of term exam grade 8 ASP. So the second part is going from question 11 to question 20. 5 points each, and in total there are 50 marks for part 2. So question number 11 is from page 744. It says, we've got two sisters, Maria and Clara. So Maria is 11 inches shorter than her sister Clara. So the first girl is Clara and the other sister is Maria, and Clara is taller than Maria. Now we've got two more girls. Luna is 11 inches shorter than her brother Chad. So we've got Chad is taller than his sister Luna by 11 inches. And also this is the key information in this question. It says if Maria is shorter than Luna, so Maria is the shortest among the four of them, how do the heights of Clara and Chad compare? Chad is taller than Clara, right? Clara is shorter than Chad when Maria is shorter than Luna. Okay, but if Maria and Luna are having the same height, then Chad and Clara will have also the same height. So it says Carla, Lola, and Mandy live in 3 houses that are on the same line. Lola lives between Carla and Mandy. Okay, Carla and Mandy lives a mile apart, so there is 1 mile between Carla's house and Mandy's house. Is it possible for Lola's house to be a mile from both Carla's and Mandy's house? So the question is telling us that they live in 3 houses that lie on a straight line, on the same line. So this is the house of Carla and this is Mandy's house, and we know that Lola lives in between, somewhere in between. So just choose any location in between and locate the house of Lola. We know that the total distance between Carla's house and Mandy's house is 1 mile. The question is it possible for Lala's house to be a mile from both Carla's and Mandy's house? For sure it's not possible. Why? Because the total distance between the Carla's house and the Mandy's house is 1 mile, and Lola is in between. So it's not possible to be more than or to be a mile apart. It needs to be less. It must be less than a mile from each house. Question number 12. This is find the measure of angle C if C and A are congruent and the measure of A equals 3x. The measure of angle B is x plus 20 and A and P are supplementary. So I'm going to start ahead by this piece of information that A and B are supplementary. So if you add A and B, they add up to 180. A is a 3x and B is x plus 20. 3x plus x is 4x plus 20 equals 180. Subtract 20 from both sides, you get 4x equals 160. Divide by 4, you get x equals 40. We are not looking for x. This is not the final answer. We need to find the measure of angle C. The measure of angle C is the same as the measure of angle A. So if the measure of angle A is a 3x, that means 3 times 40, which is equal to 120. So the measure of C will be also 120. So if the measure of angle A is 120, the measure of C will be 120, and this is what we are looking for. It says draw an angle which is named WXZ such that it measures 45 degrees. This is an angle WXZ, 45 degrees. Construct another angle that is YXZ, which is also congruent to the first one. So I know that this is 45 and this is what? 45. Make a conjecture about the measure of WXY. WXY will be a right angle that measures 90 degrees. WXY is a 90 degrees. Now it's given that both angles are congruent and each measures 45 degrees. This is given. And if two angles are congruent, then they are equal. This is the definition of congruent angles. This is the definition of congruent angles. If two angles are congruent, then they are equal. And if we replace the measure of angle YXZ by its value, which is 45, this is substitution. We are just substituting the value. We are substituting the value. And by the angle addition postulate, if you add, I'm going to name it here angle 1 and this is angle 2. If you add them up, you get the measure of angle WXY. And this is 45 and this is 45. So you are just substituting 45 instead of each. 45 plus 45 equals 90 by also substitution. So the measure of WXY will be 90 degrees. So we've got this graph and we have to identify the transversal connecting each pair of angles. Then we will classify the relationship between each pair of angles as an alternate interior, exterior, corresponding, or consecutive. So if we look at the first pair, 4 and 5, 4 and 5 lie on the same side. They are corresponding and they are connected by this transversal. They are connected by this transversal. So they are connected by line A and they are called consecutive interior. Consecutive interior. Let's have a look at another pair. 5 and 15. 5 and 15. 5 and 15 are connected by line D as a transversal and they are alternate exterior. Alternate means they lie on different sides and in the exterior region. So they are connected by line D and they are alternate exterior. And now we have 12 and 14. If we highlight 12 and 14, they are connected by this line, which is B, and they are called alternate interior. They lie inside and they are connected by transversal B. I'll do one more like 5 and 13. How about 5 and 13? I'm doing question 17 now. Question 17. Question 17 is about 5 and 13. They are both connected by transversal D. And they are corresponding angles. One lies inside, one lies outside, and they both lie on the same side. Not, you can say on the right or on the left. So they are corresponding angles and they are connected by line D. Okay, follow the steps and memorize these terminologies and this classification. You will be fine in the exam. Find the value of the variable in each figure. If these two lines are parallel, then the exterior angles are congruent. But if we set them equal each other, we will have two unknowns, x and y. Instead, we can say that this angle here, this angle and this angle Sorry, not this one. One second. 5x and the 40 will make a linear pair. So 40 plus 5x will be 180. If you look at these two angles, they form a linear pair. Subtract 140 from both sides, you get x to be 28. X is what? 20, 28. We're not done yet. We need to find y. So we know that the exterior angles are congruent. This angle and this angle are exterior angles. They are congruent as long as these two lines are parallel. So set them equal, replace x with the 28 and solve for y. 5 times 28 is 140 plus 1 on both sides, and then divide by 3, you get y equals 47. We're done. Question 30. If these two lines are parallel, that means the corresponding angles are supplementary, but they have two variables. We need to find one first. This angle and this angle are alternate interior. That means they are congruent. So we set them equal to each other. 7x equals 8x minus 10. Get the 7x on the other side. Get the 10 to the other side. X will be 10. X equals 10. After finding x, we can find y in many different ways. We can say that 7x with 6y plus 20 form a linear pair, or the corresponding angles are supplementary. So yeah, I will go for the linear pair. These two angles form a linear pair, as you can see here. Add them up, they add up to 180, and x is 10. So replace x with 10. 70 and the 20 is 90. 70 and the 20 is 90. Subtract 90 from both sides and divide by 6. You get y to be 15. We found x and we found y. So in this figure, if the measure of angle 3 is 75, if the measure of angle 3 is 75 degrees and the measure of angle 10 is 105 degrees, and also we know that line z and y, or y and z, are parallel, find the measure of each angle. Angle 2 is supplementary with angle 3. So 3 and 2 are supplementary. Angle 3 plus angle 2 will be 180 because they are supplementary. If this is 75 and you are looking for the measure of angle 3, you subtract 75 from both sides, you get 105. Angle 5 will be congruent to angle 2. 2 and 5 are congruent. They are vertical angles. So this is 105. This will be 105. Okay, the measure of angle 7. 7 and the 3. The measure of angle 3 plus the measure of angle 7, they form a linear pair. 7 and, or you can say 2 and 7 are alternate interiors. So the measure of angle 2 is the same as the measure of angle 7, which is 100. The measure of angle 3 is, it's 75. Plus the measure of angle 7 equals 180. So also the measure of angle 3 will be 105. The measure of angle 15. 15 and 10 are alternate interior angles. 15 and 10 are alternate interior angles, so they are congruent, 105 each. The measure of angle 14 10 and 14 are supplementary. 10 and 14 are supplementary. So the measure of angle 10 plus the measure of angle 14 equals 180. If the measure of angle 10 is 105 plus the measure of angle 14 equals 180, subtract 105 from both sides, you get 75 for 14. And angle 9 and 14 are congruent. Angle 9 and 14 are congruent because they are vertical angles. So 9 and 14 is 75 each, are both 75 each. Classify lines as parallel, perpendicular, or neither. We know that if two lines are parallel, then they will have the same slope. If two lines are perpendicular, then if you multiply their slopes, they should give you -1, or they should be negative reciprocal to each other. Okay, so the slope formula is here. To know whether two lines are parallel or perpendicular, you must find their slopes. So for the first line, AB, you name the coordinates x1, y1, x2, y2. This is very important to name them, girls. You have to name them. And then C and D should be the same. Find the slope of the first one. You go 4 minus 5, and then 4 minus 1. This will be -1/3. Do the same for the other line. For CD, you will get -1/3. If two lines are having the same slope, then they are parallel. They are parallel. Number 2, name them x1, y1, x2, y2, x1, y1, x2, y2. Find the slope of each one. You get 2. You get 2. They have the same slope. That means they are also parallel. You will do all the questions from 1 to 15. I'm not going to solve all of them. I'm jumping to question 7 and 8. For A, this point, and for B, it's this point. For A, you can say -1, -2, -3, -5, and -4. And for B, it's 1, 2, 3, 4, and 1. Okay? And name them x1, y1, x2, y2. Do the same for C and D. If you look at C, it's -2 and 3 units up. And this is -4 and -4 and -3. So all you need to do is apply the same slope formula to find the slopes. Here, if you multiply them, you will get -1. If you are getting -1, that means they are perpendicular. They are perpendicular. They are perpendicular. Or if you look at one number, if you flip it, it becomes -3/1. Change the sign, it becomes just a 3. So they are negative reciprocal to each other, so they are perpendicular. These two lines, again, find the 4 points J, K, L, and M. Name them, find the slopes -4 and -5. They seem to be parallel, but they are not, because different slopes. So this is neither. They aren't parallel. They aren't perpendicular. Okay. So here, this is the slope intercept form. The slope intercept form y equals mx plus b, and we are looking for m. And also we have another equation, which you still remember it, y minus y1 equals n bracket x minus x1. Remember, we are just comparing the slopes. We are comparing the slope, these numbers. So this is 2, and this is 2, Let me make sure it's written in the standard form, يعني the slope-intercept form or the point-slope form. They are parallel. Question 11. This is negative half, and this is 2. And if you multiply them, you get negative 1. Negative half times 2, you are getting negative 1. So they are perpendicular. Here, this slope is 3, this slope is negative 1/3. As these two slopes, we've seen them in the previous slides, they are perpendicular. This slope is 6, this slope is negative 1/3. They have nothing to do with each other. This is neither. Here, this is very important. Why? Because whenever you have this line, x equals -2, this is a vertical line. And y equals 10 is a horizontal line. If you have a vertical line and a horizontal line, they are always perpendicular. Slope, the first slope is undefined, the second slope is 0, so this is perpendicular. Or you know that the graph of x equals any number is a vertical line, y equals any number is a horizontal line. They are perpendicular. Y equals 5 here, if you just graph them, this is 5. Y equals 5 is this line. This is y equals 5. And this is y equals -3. And they are both what? Horizontal. That means they are parallel. If I tell you that 3 and 7 are congruent, can you tell me which two lines will be parallel? Yes. 7 goes to A, 3 goes to B. So line A is parallel to line B because 3 and 7 are alternate interior, and this is the alternate interior converse. 2, which is 9 and 11, 9 and 11 also goes for A and B. So A will be parallel to B, and they are corresponding. So this is the converse of corresponding angles theorem. 2 and 16. Yeah, 2 and 16 are alternate exterior. Are what? Alternate exterior. So this 2 goes to L and this 16 goes to M. So L will be congruent to M. They are alternate exterior. So this is the alternate exterior converse. If the two supplementary, 5 and 12, are adding up to 180, then L and M are parallel, and this is the corresponding, they are consecutive interior this shouldn't be exterior, this is consecutive interior. Yep, consecutive interior, sorry. One and six. 1 goes to G, 6 goes to H, so G and H corresponding converse, right? Because they are corresponding. 7 and 6, whereas 7 and 6. Let me erase this. this point. Now we've got two consecutive angles. They add up to 180. Sorry. P and Q will be parallel. P and Q will be parallel. Consecutive again, interior, consecutive, interior. Determine whether triangle P prime, Q prime, R prime, which is the big one, is a translation image of triangle PQR. Look, they don't have the same size, so the answer is no. The size has been changed, right? And determine the translation vector that moves every point of a pre-image 4 units left, means, and 6 units up. 4 units left means -4, and 6 units up means +6, and we use the vector notation, so -4 and 6. Yolanda reflects an object in the line y equals -1. And you know that y equals -1 is a horizontal line, and then she reflects the same object again in the line y equals 1. So we've got two lines, y equals 1, -1 and y equals 1. So what's she doing? She's reflecting, let's say we have an object here. This object is reflected here, and also it's reflected here. The distance between y equals -1 and y equals 1 is 2. Describe the translation. The translation will be just double the distance between the two lines of reflection. So it will be doubled. It will be 4. So the distance between the lines is 2. So we will add double the distance to y. Determine whether each statement is always, sometimes, or never true for translations. Justify your argument. Lengths and angles, measures of the image, are preserved. This is always true, right? Translation doesn't change the size or the orientation of the pre-image, right? So it's just moving the original shape left and right, up and down. So it's always true. All the segments drawn from a vertex of the pre-image to the corresponding vertex of the image are parallel, 100%, right? Okay, why am I skipping B? So this is also always true, because all the points of the pre-image slide along the same vector, so they will be parallel, these segments. Vector AB will translate each coordinate of a pre-image A units right and B units up. This is true if A was positive, and this is true if B was positive. So it's not always true. If A is bigger than 0 and B is bigger than 0, yani both positive, then the statement is true. But as it is, it's sometimes true. So you've got a triangle with the given vertices. It represents the area on a map covered by a field of fishing ships. So first, let's draw the triangle. Let's draw the triangle. So this is -3 and 1. This is -3 and 1. And this is -1 and 4. And this is here 1 and 1. So this triangle, or this region, is translated along a vector (4 and -5). That means 4 units right, because it's positive, and here 5 units down. So if you look at each vertex, it will move 1, 2, 3, 4. 1, 2, 3, 4, 5. This is the first vertex. This one, 1, 2, 3, 4. 1, 2, 3, 4, 5. The other vertex. And now this one, 1, 2, 3, 4. 1, 2, 3, 4, 5. You've got the 3 points, then match them, you get the new translation. Steve found that the hubcaps shown below it has at his local junkyard determine whether each one has a rotational symmetry. So the first one, rotational symmetry, means if you rotate a figure, okay, around its center, it maps again onto itself within a full rotation of 360 degrees. So if we rotate this wheel or this cap, okay, this will come here. So it will map itself. Another, like, continue rotating it, it will become here. So actually it has a rotational symmetry. It has a rotational symmetry, right? So all of them will have a rotational symmetry. And this flag for the United Kingdom, does it have a rotational symmetry? Yes, because if you rotate this around its center, okay, after 180 degrees, it will be upside down, but it will look the same, means it will map onto itself, right, within one full rotation. So yes, the flag can map onto itself with a rotation that is less than 360 degrees. Yeah, in one full rotation, it maps again onto its original position. And here, if you rotate this one around the center, this arrow will become here, so it will look the same. Continue rotating it, it will become here, so it will look the same. So yes, it has a rotational symmetry. But this one, if you rotate this one, okay, if you rotate this one, it will look the same after a full rotation of 360 degrees. After a full rotation, not within a full rotation. So this is gonna be, no, it doesn't have any rotational symmetry. Yes, determine whether each figure has a rotational symmetry. If so, find the center, order, and magnitude. So this is the, if you rotate, no matter clockwise or counterclockwise, this one will come here, and then it will come here, and then it will come here. So the order equals 3. The order equals 3, or you can just say 1, 2, 3 if it's uniform, right? And the magnitude, it has a formula. It's equal to 360 degrees divided by the order. So 360 divided by 3 will be 120, right? Question 12. 1, 2, 3, 4, 5, 6, 7, and 8. They will replace each other within a full rotation, so the figure will look the same. So the order is 8. And the magnitude equals 360 divided by 8, which is 45. This one, this will go down here and this will go up here within a full rotation around the center. So the order is 2 and the magnitude is 360 divided by 2 equals 180. And this one doesn't have a rotational symmetry. Question 19 is about the congruence criterion. So these two triangles are congruent, find y, and then find x. If you look at this here, this angle and this angle are congruent. So if this is 48, y will be 48. So because the measure of D and B are both congruent, so it's 48 both, right? Now for this triangle, if you are looking for the measure of angle A, it will be 180 minus 108 minus 48, because I know that the three of them add up to 180. So if you subtract 180 minus 108 minus 48, you will get 24, I guess. Yeah, it will be the measure of angle A is, yeah, wait a second, I got confused here. We are looking for the measure of angle A. So the measure of angle A is 108 minus 180 minus 108 minus 48. And if you subtract these angles, you will get 180 minus 108 minus 48 is, I told you, 24. Yes, it is 24. So the measure of angle A and F are both congruent. So the measure of angle A and F are congruent. So here we're just finding the measure of angle A. So the measure of angle A is 2x minus y. If this looks a bit complicated, we can just say that angle A and angle F are congruent, right? The measure of angle A is 24. The measure of angle F is 2x minus y. We already found y, which is 48. So plus 48, plus 48, 2x equals 72, divide by 2, divide by 2, x will be 36. Still in 19, find the value of x, find the value of x. And x is for angle A, right? Look, angle A is the first letter, so it's congruent to angle P, the first letter. So angle A is 2x plus 4, and angle P is 100. So 2x plus 4 equals 100. Minus 4 and minus 4, 2x equals 96, so x equals 48. Find the value of y. Y lies here for DC. And DC or CD is the last two letters with the last two letters with RS. So 12 and 3y minus 13 are the same. Plus 3 on both sides, divide by 2, you get 4. Okay, wait a second, there is something wrong here. This is 15, and 15 divided by 2 is just 7.5. Am I right? Yeah. Still, we're human beings, so we make mistakes. It's okay. So this is 7.5. Yeah, I think so. Question 20. An engineer is designing a new cell phone tower. Part of the tower is shown in the figure. The engineer makes sure that line M is parallel to line N and that AB is congruent to CD. AB is congruent to CD. So these two segments are congruent. Can the engineer prove that these two triangles are congruent, the red and the black triangle? Let's see. So the first pair of sides are congruent, and by the reflexive property, this side belongs to this triangle and to this triangle. So I've got S, I've got here S for this one, I've got S for this one. And also we can say that angle ABC, this angle and this angle are congruent. Remember when I told you that they form something called the Z shape, like this? So these two angles are congruent. So I've got angle now, right? I've got an angle. So they are congruent by side, angle, side. By what? By side, angle, side. If you need to like separate these two triangles, they are like this. Okay? This side and this side are congruent. And this side and this side are also congruent. This angle and this angle are congruent. So they are congruent by side, angle, side. Determine which pair of triangles cannot be proved to be congruent using the triple S or SAS postulate. Now, this is S. This is S, right? And also, this side is S because this side belongs to both a triangle, right? And we can say also side, angle, side. So this is okay. Now this one, S, and this side belongs to this triangle and to this triangle. So we can use a triple S here. But in the first one, we know that this angle is equal to this angle and this side is equal to this side. So I've got A, I've got S, but where is the other S? We don't know whether any other pair is congruent or not. So this one is out. So the first pair, it cannot be proved using the given postulates. Two pairs of corresponding sides of two right triangles. So let's graph two right triangles. Okay. Two pairs of corresponding sides of two right triangles are congruent. Are the triangles congruent? For example, we know that this is H and this is H and this is leg and this is leg and this is leg and this is leg, right? Two legs and one hypotenuse each. If I know that this and this are congruent and this are congruent, or the other leg, then this is the first case. By what? By using hypotenuse leg. Or you can say that this side and this side are congruent, and this side are congruent. Okay? That means they are congruent by leg. And by the Pythagorean theorem, if two sides are congruent, then the third side is congruent. So we can use triple side. We can use side, angle, side. Right? Yeah, so read the cases. Read the cases and refer to this simple sketch of right triangles for your reference. This is the end of part 2. I hope this helps, and all the best. See you in part 3. Bye-bye.